Section 4.5, problem number 7 for the teach us video about derivatives and the shape of the graph. Is asking us consider the function f of x equals 4 times x minus 4 parentheses around it to the power of 2 over 3. For this function, there are two important intervals, negative infinity to a and a to positive infinity without the brackets on both of them. And it tells us a is a critical number. So first thing we do, we find the derivative, the first derivative, where I actually have it over here, where we basically have like we do a product rule, and then within the product rule we do a chain rule. So here we have the first derivative of the function is 4 prime times x minus 4 parentheses around to the 2/3 power plus 4 times, this is where the chain rule comes in, 2 over 3 times x minus 4 parentheses around it to the power of negative 1 over 3 times 1. We get this one from the derivative of x minus 4 of that term when we're using the chain rule. And then we get a over 3 times x minus 4 parentheses to the negative 1 over 3 power. We could simplify this one further and make the exponent a positive, becoming 8 over 3 times x minus 4 parentheses around it over positive to the power of positive 1 over 3. And when we plug this equal to 0 and find our critical points, we know that x equals 4. And when x equals 4, this function becomes undefined. There's nothing we can do to the numerator because there's no x value, or there's no unknown value on the numerator, which is partially the reason why I did this. I just set the original function equals 0 and solved, and I also got 4, positive 4 for the critical number. So, and then the next thing it does is it asks us for each of the following intervals, tell whether f of x is increasing or decreasing. So now that we have our critical number of x equals 4, we can do like a little number line, and then we just pick a value on each side. I picked 0 and 5. So with these two numbers, we basically plug it in to the first derivative function. So I already did the calculations, and basically when you're doing this, you're not exactly looking for a specific number in mind. What you're looking for is to see that the value you get is a positive or negative. So when f prime 0, I get a negative value. So basically I'm plugging the values 0 and 5 into this function here where I'm highlighting it, and f prime of 5, when I plug this one in, I get a positive value. So for the first derivative, when you plug in a value and you get negative, you know that it's going down. And if you get a positive value, you know that it's going up on the graph when you're reading from left to right. So therefore, negative infinity a is decreasing, a comma positive infinity it's increasing. But now we take a step further. So not only we want to know if the function given like a certain interval, if it's like increasing or decreasing, we also want to know like the shape of that interval. This is where the second derivative comes to play. So the final part is for each of the following intervals, tell whether f of x is concave up or down. So yeah, this is where the second derivative comes into play. And taking a few steps back, I did mention that when finding the first derivative, I wanted to keep my answer in a negative exponent. And the reason I do that is with the negative exponent, I'm able to simplify things a bit by avoiding the quotient rule. So instead, I will use the product rule. And here is where should I use the product rule. And in this product rule, there's also a chain rule that we use. So the second derivative, we get a over 3 prime times x minus 4, parentheses around it, to the negative 1 over 3 power, plus 8 over 3 times negative 1 over 3 times x minus 4, parentheses around it, to the negative 4 over 3, chain rule. And then we also have this times 1. This 1 is from the derivative of x minus 4. And then I get negative a over 3 times x minus 4, parentheses around this, to the negative 4 over 3 power. And the next step, I decided to write it in a positive exponent, which I get negative 8 over 3 times x minus 4, parentheses around it, to the power of 4 over 3. And now that we got our second derivative, which I'm going to highlight, we do something similar. We take the same the number line we did, so 4, our critical point, and center, and we pick two values, which I did this. I chose the exact same values, 0 and 5, and same thing, same idea, pretty much. I plugged 0, like second derivative f double prime of 0, plugged it in. I get a negative value, f double prime of 5, and I also get a negative value. So when you get a negative value, we get concave down, but we also need to keep in mind that if our first derivative is increasing, but our second derivative is decreasing, we get ourselves a concave down, but instead of it literally moves downwards, it moves upwards. So I'm going to highlight what the concave looks like here. So for the interval where I pick 0, reading from left to right, it's decreasing and it's moving down, concave down. So this is what it looks like, which I'm going to circle it. And then the interval where I picked 5, our first derivative was positive, was increasing. So, but then when we plug that same value of 5 to the second derivative, we get a negative value. So that's concave down. This is, so moving from left to right, it's increasing while it's a concave down. So it'll just look like this, which I want to circle it again. And yeah, so negative infinity comma a, concave down, positive a comma positive infinity is also concave down. And yeah, that's it.